Hi, my name is Rutlixat, and I'm here on behalf of Team 13180, Rover Drive. This presentation will introduce you to designing with Onshape, a 3D design software. What is CAD and why learn it? Computer-aided design, which is what CAD stands for, is the use of computers to aid us in creating, modifying, and optimizing designs. In other words, it sort of helps us make realistic, lifelike designs with accurate measurements on a software that's much easier than compared to drawing on paper. It's 3D, unlike paper, which is only 2D, meaning you can see it from multiple viewpoints, whatever you're designing. And that way you can have a more accurate representation and idea of whatever you're designing. It is actually used by multiple professions, from engineering and architecture, robotics, all the way to even interior designing and product design. Now, why should you use it in FTC? First of all, it helps you quickly prototype your design ideas before you build. One thing that's happened to our team a lot of times is that we haven't really planned out our idea, or we haven't designed something, and we end up building it only to realize it doesn't work or it broke apart. Using CAD, you can actually foresee these problems and actually prototype your design without wasting any materials or even money. So it's really a better way to prototype and prepare without wasting any materials, and it's also a lot quicker, so you don't waste that much time. And you can also keep revising your design until you get it right. You can review it, make minor changes until you have the right design. Then building that design is as simple as following an instruction kit, like a Lego instruction blueprint. It's extremely simple, and CAD basically makes sure you can discover faults in designs without any repercussions, such as wasted parts or money. It helps you as a team. First of all, it helps your budget, and it also helps you come with better design ideas and find faults in these better design ideas. Now, Onshape. Onshape is a web-based 3D modeling and design software. The advantage of this is that you don't have to download anything really big onto your computer. It's all on the web, just like Google Drive, Google Docs. And also, it won't take as much of a toll on your computer as downloading like Fusion 360 or any other CAD program that you actually have to download. So that's one of the biggest pluses of Onshape. Additionally, it has real-time collaboration tools. This is sort of like Google Docs, which allows you to work on a document at the same time as another person, see what they're doing, see where they are. All of that is also in Onshape. You can actually follow people and see exactly what they're doing and see their screen. Additionally, you can see what they're doing, and you can do something else, and all changes will appear in real time. So if you move something around and press the green check mark, which we'll see later in the UI, then it would appear on your teammate screen as moved. Additionally, you can also put comments, which makes communication or reminders or instructions to other teammates much more simple. And one really big plus is it's free for education purposes. This means that if you are a student, you can get free Onshape. Some CAD programs are extremely expensive, but most of them do have free programs for students. So for the free Onshape, all you have to do is follow the instructions at the tinyurl.com/free Onshape. It's a tiny URL we just created, so that if you just click on it or type it up, you should be able to go to the Onshape page where you can sign up for the free student program. After you fill out the instructions, which will include writing your name, email, password, and school website and school name, you should be able to get free Onshape, and all you have to do is activate it from your email. Finally, Onshape, as all CAD programs, helps organize and create designs and determine possible problems with these designs, which is, once again, the main reason you should use CAD. Onshape possibilities. So here we have a picture of our robot that we designed for a specific design competition over the summer that FTC hosted, Robots to the Rescue. Here is a robot that is made that's supposed to sanitize stores, offices, sort of anywhere it's designed. And it's designed to actually clean anywhere using sanitation, a sanitizing bottle, a bottle full of sanitizing liquids, and a wiper here that spins around, sort of like a toothbrush, to clean areas, as well as a floor wiper. And although it is hidden, there is an ATP detector, which will determine if a surface is clean or not. Here you have elevators, and you have a chassis that will move your robot around. All of this was possible on Onshape, and as you can clearly see, you can basically make any part of your robot on Onshape or import it. So Onshape is clearly one of the best programs and resources for designing an FTC. All right, now I'll be showing you an Onshape user interface demo. I will show you the interface, how it works after you've activated your email. So I have created a new Onshape account. So this is what you will see when you first log into Onshape after activating your email, this page. As you can see here, you have welcome to Onshape. The Learning Center is right here if you want to reach it another way. And the Learning Center basically has a bunch of tutorials and videos for you to learn more about Onshape. It's a very handy tool, and I recommend that you check it out after this video. Additionally, you can get started by clicking the Create button. We will get to that, but Create button generally means you can create a document or folder to organize your work. And additionally, you can import files. And label to further organize your work. We'll get into importing files. And as of right now, we will go through the rest of the Onshape UI. All right, here you have My Onshape. My Onshape consists of all the documents that you've created and all the documents that your team has created, or basically any document that you have gained access to, whether it's the public documents or it's your own document or it's imported or your team has created it. Then you have the recently opened. These documents are your most recently opened documents. You have created by me. These are documents that you were created by you. Shared with me, document shared with you. And then public. Public has a bunch of different cool things that other people have made that you can definitely check out if you want inspiration or if you just want to see some really cool prototypes, some really cool designs. And finally, there's trash. This is where your documents go if you decide to throw it away, and you can either choose to recover or delete forever. All right, now here we have the search bar. This is just to search for any documents that you may have you're not able to find. As you can kind of tell, the UI is sort of similar to Docs or Google Drive in this way, as well as the recently opened created by me, shared with me. And now over here, in this corner is the account settings. So right now I'm going to show you how to actually make a team. So if you make a team, you'll be able to share documents extremely easily, and all of your team members will have access to the documents and will be able to edit them, work on designs together, and it's highly recommended that you make teams. So you're going to click on your account and you're going to go to My Account. Once you're in My Account, if you see right here, there is a team section, you're going to click on that. Then, just like mine, yours should be empty. You're going to click on Create, and then you're going to name your team whatever your actual robotics team name is, or actually whatever you want if you're using it for something else. So in this case, I'm going to name it Rover Drive. Then your description is optional. I'm going to say Team 13180's, let's say CAD Playground, to test and design robotic parts. It is optional, so you don't have to fill out a description, but I will in this case. Then you're going to click Create Team. Then you will be given this screen. This will either add team members or search up team members. Generally, I'd recommend adding team members. In this case, you would have to just get their emails, assuming they've already signed into Onshape or created an account. After all of your team members have created an account, you can just type in the emails, and you should be able to add them to your team. All right, as you can see, this slide is about importing parts. When you're making robots in real life, you don't really create every single part. You have to import some parts or buy some parts from FTC approved suppliers like Rev, Tetrix, Andy Mark. And these might be a bit harder to design or to get all the accurate measurements. For example, motors have a bunch of components that you can't account for, as well as servos and other sensors. Additionally, channels are quite complicated with the different patterns they may have. And it's just a lot of extra work to actually design these. That's why most of these suppliers that you may buy items from will have CAD files that you can download. So these would be like motor files, sensors, servos, structural components. Almost all of these will have CAD files that you can simply download and import into Onshape. This way you don't have to waste your time designing specific parts that, well, are pretty easy to just download from and are actually quite hard to design. So now I'll show you how to import some parts. We will be importing 6 parts, which will be used in exercises in the later portion of the video. Our first part will be the Tetrix Max channels. Then we will get the Rev extrusion, 15 millimeter extrusion, 420 mm length, 90-degree ends. Then we'll have a 6 mm round ID shielded flange bearing, Tetrix Prime 6 mm steel axles, Tetrix Max wheels, and Tetrix Max motor shaft hub. Now, to download these parts, all you simply have to do is scroll down. Most pages will have a download section. On the Tetrix page is right there. And in the downloads, you'll see multiple CAD files. In this scenario, because there's multiple lengths for these channels. So we can simply click on the 288 mm and we're going to click download now. Then you will have a .step file downloaded. Make sure that the files are .step because that's what Onshape supports. Then we'll move on to the Rev website. And as you can see, if you scroll down, there should be a CAD section. We're going to click on that step file and that will download it for us too. The same is for Andy Mark. If you scroll down, you will have a CAD file section and you're just going to click on the step file. So you're going to make sure you download all of these, on all 6 of these onto your computer. All right, after you've downloaded all 6, you're going to click create on your Onshape dashboard and you're going to not click document or folders, you're going to click import files. So I'm not sure if you'll be able to see the pop-up that happens when I click import files. If you are, you'll see your computer system finder. So after you find that, you'll be greeted with all the parts you've downloaded. So this would mean that you have to upload these 3 parts. And you're just going to click open. Then you'll be greeted with this: import to a single document, or split into multiple documents, or combine to a single part studio. What you're going to click is you're going to click import to a single document. This will mean that it will be created in a document of its own. Then you're just going to simply press OK. After you click OK, all 6 of your files will show up on your dashboard, and it will be under My Onshape or created by me. And as you can see, we have a picture show up for each document. So these are what documents will look like on your Onshape, and it'll show like a snapshot of so the contents inside the document. Here we have our axle, here we have our motor shaft hub, our wheel, our channel, our rev extrusion, and our ball bearing. Now we'll go back to the presentation. Using Onshape for FTC assemblies. With a few basic techniques, one can already start assembling robots extremely simply. The 3 mates that you will need are the Fasten Mate, Revolut Mate, and Slider Mate. Now you might be wondering, what are mates? Mates basically combine 2 parts together in a specific way. So that way, these parts will be associated with either some motion or no motion. And with the combination of these mates, you'll be able to create your entire robot. Our first mate we'll go over is a Fasten Mate. This Fasten Mate will attach 2 parts together on selected faces. This means that it will sort of, if you choose a specific face or a hole, if you're using a channel, then you'll be able to attach these 2 together and make sure that there's no movement. If you recall what screws and nuts do in Onshape, it's quite similar to that, except that if you only put 1 screw and nut, you will be able to rotate your assembly, whatever you put together, around. While in Onshape, you won't be able to do that. It'll be a solid, rigid motion. This is why you won't have to put multiple screws or multiple Fasten Mates. So basically, Fasten Mates attach 2 parts together with no movement, just like screws and nuts. To attach 2 channels together, use the Fasten Mate. That's an example of how you use it in real life compared to how you would use it in Onshape. If you want to attach 2 channels together, you could either use 2 or more screws or the Fasten Mate. Now we'll have a demonstration of the Fasten Mate. For the demonstration, we are going to be creating a new document. We're going to click Create, and we're going to click on Document. Then we're going to name our document. I will name it Fasten Mate Demo. Then we're going to click Enter. Then Onshape will load up our document. Notice you will also be greeted with an introduction as this is the feature toolbar, the feature list, the tabs, and the view cube. And then it will give you a link to the Learning Center. So the feature list is the toolbar is basically where you will have all your tools, including your mates. The feature list is right over here. This is going to show everything you make. Then these tabs are important. We are going to be switching to the assembly tab right here. So Part Studio is when you're creating your own parts, which is not as important in FTC as assemblies. So we'll be going over assemblies in this presentation. If you want to look over the Part Studio and creating and sketching parts, just go to the Learning Center and watch one of the videos there. So in the assembly portion, we have our toolbar. It's in the same layout as the Part Studio, except our toolbar has different tools, which include our mates. In the feature list, we will see the origin and not the planes because we're not sketching, and the parts, as well as the mate features. And finally, we have our view cube. This changes the angle you look at the objects in your document. You won't be able to see any change because right now we don't have anything, but after we insert some objects, you'll be able to see a change. Our first step is going to be to insert our channels for the Fasten Mate. We're going to go to Insert, and rather than go to Current Document, this is what you'll use to import parts or assemblies that you've already made in this document. You're going to click on Other Documents. Then in Other Documents, you'll be treated to the same menu as your dashboard, which will include My Onshape, recently opened, created by me, shared with me, and your team after you've created it. This will just consist of all the folders and files that you have created and shared with your team. For us, we're going to click on My Onshape. Then we'll be greeted with our 6 parts that we've downloaded and imported. We are going to click on the 3906828mm channel. So keep in mind, one common mistake is if you double click, you'll actually get 2. So you only have to click once. But in our scenario, we actually do want 2. So we're going to click twice. If you click once, you'll see this right here will say inserted 1. If we click again, it will say inserted 2. And you'll be able to move the channels. So to stop them moving, you just have to click once. And we'll have inserted 2. Then we're going to click the green check mark, the one I was talking about earlier. This will signify any movement and say, or anything at all, and say that, yes, it's completed, we're good. So after you do the green check mark, we'll have 2 channels here. The first step we're going to do is click on the cube, or the channel. After we click on the channel, you'll be greeted with this arrows. These arrows will help you move in a specific amount. So let's move this. You'll be greeted with a text box that says 0 inches. We're going to type in 5 inches. Then our channel will have moved, and we'll see that there's actually 2 channels just completely overlapping. Now I can actually show you what the view cube does. This will change your view. So if I click top, we'll be able to see them from the top. I click right here. This will show them from a merge of the top, front, and right. We have front, right, and the back. Additionally, we have these arrows. These will move your screen down or up, and right or left. Additionally, we will also be able to double click, right click. If we right click anywhere on the screen, we'll be able to move our view around in a smooth manner rather than pressing. So we'll be able to do it to a custom viewpoint. So this way you'll be able to see your designs in 3D. All right, so now we will be doing our Fasten Mate. Our Fasten Mate's located right over here. We can either click on the Fasten Mate right there, or we can click on the letter M on your keyboard. Then you will appear with this little box. This box is the mate box. This is what will show you your mate connectors and your offset and all of these, which will all be explained. First, our mate connectors. What mate connectors are is basically the parts that you want to connect together. So each object will have their own mate connectors. So our first, we're going to zoom in on our first channel, and you'll see we have multiple mate connectors here. So we're going to click on our hole right there. This would be where one of the screws are. Normally you'd have 2 or 3 screws, like I said earlier. We only have to have one point of contact for this. So one of our screws is going to go through here, and we're going to have to find a point here where on the other channel where we want the screw to go through again. So let's switch our view to the top right, front left. We're going to zoom in, and if we want to have it at a 90-degree angle, we should probably rotate this. So we're going to click on the topmost hole. All right, now you may have noticed how this is actually a bit lower. So what has happened is that it has matched the size of the rectangles. If you don't want this and you want a perfect 90-degree angle, all we have to do is click this rotation button. This will just reorient the secondary axis, meaning that it will just rotate it around the connection. So if you click reorient, we will have our 90-degree angle right here. Then all we simply have to do is click the check mark. And as you can see here, we have an L, or a 90-degree angle. Now, if you're wondering, are they really connected? If you can click on one and move it around, and you can see that they actually move together, which did not happen in our first try. That means that these are connected. So as a result, the Fasten Mate basically works as screws and nuts. We're able to connect 2 parts. All right, let's go back to the presentation. Now let's talk about the Revolut Mate. This will combine 2 objects while making one rotate around the other. This means that it will just allow rotation. Then, as you can tell, it would be used for objects that rotate, such as wheels, axles, and motors, servos. All of these will have Revolut Mates. An example would be an axle Revolut made with an axle that's Revolut mated with a bushing, which would mean that the axle would rotate inside of the bushing, or ball bearing. Now, one of the common mistakes I know in CAD is that one person's tempted to make the wheel rotate around the axle. This is generally not the case. In reality, the wheel is attached to a hub, and this hub is actually attached to an axle. So the wheel doesn't rotate around the axle, but the axle rotates around a ball bearing. This way, you're able to move the axle, and additionally, it will also reduce friction. Now, let's go do an example of the Revolut Mate. Now we're on the Onshape dashboard. We're going to click Create again, and we're going to create another document. This one we'll name Revolut Mate Demo, or I'll name it. You can name it really anything. Now we're greeted with our Part Studio. We're going to switch over to Assembly. Now here we're going to insert a couple more documents than the Fasten Mate, as the Revolut Mate example is a bit more complex. So we're going to click on My Onshape. We're going to click on other documents than My Onshape. Then we're going to click on our axle, which we'll click on once. Then we will click on our wheel, also once. Then we're going to click on our motor shaft hub. So we're going to click on the top one this time because we want to include the screw as well. Then we are going to click on our ball bearing. Same with the ball bearing, we're going to want to click on the top one so we include all of these parts. Then we're going to click the green check mark. Now, as you can see, all the parts are jumbled up. So we're going to move the wheel away. We can actually move it -2 inches. We're also going to move, actually, before we move these 2 pieces, as you recall, they are an assortment of multiple pieces. So what we're going to do is we're going to highlight over the parts, and we're going to click right here. This is called group. So group, what it will do is it will make all the parts together, meaning it will fix the position. So this will always be the same, and you'll be able to move them together, and you won't be able to move them independently. What this means is, for example, if I have, let's say, a wheel and an axle right here, and I click group, if I move the wheel, the axle will move with it. So in this scenario, if I use the group, I will click the check mark, and now this is one piece that I can click on and move to the right 1 inch. We're going to do the same thing with the ball bearing. We're going to highlight all of the parts inside of it, and we're going to click group. Then we're going to click the check again. Then if I click on one portion and move it 2 inches, the whole thing will move. All right, now let's get into actually making the Revolut Mate. So our first step is going to be to combine the wheel and the motor hub. So normally the wheel is not able to actually rest on the axle. You have to have a hub, so that way it will move with the axle. We're going to use the Fasten Mate on the motor hub and the wheel. So this is generally because the wheel is screwed into the motor hub. Additionally, we'll be using a motor hub just so that the wheel in reality won't like roll onto the axle and become all wonky or wobbly. And the motor hub will just secure it onto the axle, making sure that I'll move it with the axle. So we're going to click on the Fasten Mate, and we will have our mate connectors just as we had previously. We're going to first click on this hole on the motor hub, or you can actually click on any of them. Doesn't matter, as this is circular and symmetrical. Then we're going to go to our wheel, and we're going to click on one of the holes as well. Now, as you can see, the motor hub's actually inside the wheel, but to fix this problem, all you have to do is click flip primary axis. This means that it will change how it's attached. Either they're attached at the same point, or it will flip it over so that one is on top of the other. So now our motor hub is over the wheel, which is exactly what we want. And we can just click the green check mark. And as you can see, if I move this, the motor hub will move with it as well. Now we're going to get the motor hub onto our axle. So to do this, we're going to be using another Fasten Mate because the motor hub is fastened to the axle. So we're going to click on the Fasten Mate. And instead of clicking on one of the small holes, we're going to click on one of the big holes of the axle. As you can see, we want to go for this inside hole because that's where the axle will be resting. We can click on any of these mate connectors. I'm going to click on the top one. Then we're going to go to our axle. If you highlight over the axle only has 3 mate connectors, while the other channels have way more. This is because the only way you can really attach an axle is around it, right? So we're going to click on we can click on the top one. As you can see here then, the motor hub is at the top of the axle at the exact position that we want, and we can just click the green check mark. And now we have our assembly of a wheel, a motor, and an axle. Now, as you can see, normally wheels are horizontal. The wheels are perpendicular to the ground and the axle is horizontal. So if we want to rotate this, all we simply have to do is highlight it. And as you can see, we have actually, let me show you something. So if I click on one portion, let's say right here, the wheel, then we'll have this appear again. Now these circles with lines, these are to rotate it around. So I'm going to click on this one and I'm going to move it 90 degrees. And as you can see, all parts moved, even though I only selected one part. This is because they're all fastened together. So now we will do our Revolut Mate. We're going to click on the Revolut Mate, which is right next to the Fasten Mate here, and we're going to click on it. Then we'll have the mate connectors highlighted. Remember, in the Fasten Mate, this is just where the connectors. So we're going to click on 2 connectors. Our first connector will be inside our ball bearing. If you zoom in, you'll be able to see that there's three different connectors inside the center of it, just like the motor hub. We're going to click on the center one. Then we're going to go to our axle and we're going to click on the center one as well. As you can see, our bearing is right here and it is right in the middle of our axle. However, we don't want it at the middle of our axle. When you put on a wheel, you may want it in the middle, you may not. It might change depending on the side of your channel, the size of your axle, the size of your wheels. So if you want to change your distance, like we'll do in this scenario, we're going to click on offsets. So this offset on the Z-axis, that's this blue one right here, is the sort of the space where the bearing is going to be or where the axle is going to be. So we actually want it to be closer. We want the bearing to be closer at the left end of the axle. So as you can see, since the Z axis is pointing here, we're going to want a positive distance. So let's type in 1.5 inches and click enter. As you can see here, the bearing has moved to the end, exactly where we want it. And yeah, that's about it. Additionally, you can also put a limit if you're using like a servo that only moves 180 degrees. And this limit can make your servo move from a specific angle to a specific angle. Also, if you want to test, you can always click the play button, which will rotate one piece. So if you notice, when you click the play button, the ball bearing is actually moving, not the axle. This is not what we want. We want the axle to move. So all you have to do is go over here and you'll see items to reorder, the arrows. So we're going to click over here and we will have like a dragging sort of thing. We're going to click on the axle and bring it up. Basically, the one that's above will always be doing the moving. So now when we click play, our axle will be moving, which is exactly what we want. Then we can click the green check mark. Now I'm going to tell you how to actually test your mate. We're going to right click on the Rev Loop Mate and click animate, which is right under copy. Now, if you animate your mate, that basically means you'll allow it to move if it's a motion mate, like Revolut or slider. So as you can see, the mate will be highlighted. Then the start value and end value, this just shows where it's going to run from. Since it's a wheel, it's going to do a full rotation, 0 to 360. If you had, for example, a servo that moved from 0 to 180, then you would type in 180 there. It would generally show you what your limits are. So that means it would only do a half spin. Then we have the steps and the playback type reciprocate. This means that if I click play, when it goes to 360 degrees, it will start turning backwards and go diminishing. So it'll go like this, then it'll go like that. Now, one thing of note is that the entire wheel is actually moving. This is because Onshape is logical in its thinking. If you think about it, the axle is attached to the motor hub with the Fasten Mate, and the motor hub is attached to the wheel with the Fasten Mate. Since Fasten Mates don't allow any motion, this means that if the axle moves, then the motor hub moves, which means the wheel moves. So Onshape's actually quite good at sort of simulating real life and real life designs, which is another reason why you want to use it to test out your designs. Now, let's show you the actual portion of inserting stuff that you've made into your documents. Now we're going to click insert. We're going to go to other documents. We're going to click on my Onshape, and let's insert our Fasten Mate demo that we created. Now you might have an error here with no Part Studios available. So what this means is that you actually have to create a version. So what this means is if you go to Fasten Mate demo and click on this button right here, you'll be able to create a version for the Fasten Mate demo. What a version is, it sort of saves all of the stuff that has happened previously. Although, I mean, Onshape auto saves, but it will put all of the things as one version that you can revert back to. And this version will be able to be imported into other things. So if we create a version here, we are able to see our Part Studios and assemblies. And under our assemblies, we have assembly 1. Additionally, to versions, you can have the version map, which will show you all the different versions. So you can actually insert a specific version. So if we click on V1, we'll have our assembly. But if we click on start, we'll have nothing to actually import. So let's click on version 1 because we want our our assembly 1. We're going to click on assembly 1, which will be in the assemblies. If you're on Part Studio, that will be empty. Assemblies, and we're going to click on assembly 1. Then it will appear just like before, and we'll be able to move it. So we'll just click somewhere and click the green check mark. One thing I'd also like to note is that you can create versions on your original document. So as we are on the Revolut Mate document, if we click right here in the top, this will be creating a version. So if we click create version, it will be named V1. We can click create. This description is if you want to explain to your teammates what changed from the previous version. So we can click create. And then we can go right here to manage versions in history. And one thing I like to show you is if you right click on V1, we can click branch to create workspace. So what a branch is basically means that you can click on one version and edit that version, no matter of all the extra versions. So you can create multiple branches as well. So what this means is after you've built like a base chassis or like a base structure, the chassis is like the wheelbase. So after you have a structure made and you want to, for example, test different action components on that structure. This is just like maybe like an arm that throws or like a shooter that spins stuff out. Then you can click on the version of the structure, and you can create a new branch off that structure. This means that you can actually create 2 branches or multiple branches, and in each branch you can design one form of the action component. This means that you can create a shooter or a launcher without disturbing each other's progress on the same structure, just to test out which one works better, which one seems better, which one will not break your robot. So that's a really handy feature. So if you click create, you'll be able to see your branch. And it sort of branches off, so it won't affect your final version. So one thing, I'm going to delete the branch. All right, so that's basically how you're able to insert. You're going to have to click on return to main additionally too. You won't be able to like edit specific versions. You can return to main to actually edit. Now, that's just how to insert documents that you've created or your teammates have created into another document. And just to finish this off, let's assemble these two together. We're going to click on the Fasten Mate. We're going to zoom in onto our ball bearing. And we're going to click the piece that circles the wider part, but not the widest part. Then, as you can see, we have 3 connectors. We're going to click on the top one. All right, now that we've clicked on that portion, we can go to the top right front view by clicking on the back circle over there. We can zoom in on our channel. Let's X that. Zoom in on our channel and click the final hole, the big hole, and the center and the outermost portion. Then you can you'll notice that none of the actual bearing is intersecting into the channel, and it's goes straight through the hole without intersecting anything, which is perfect. Then we're just going to click the green check mark, and if we zoom out, zoom in again, we can see that our wheel is right there. And if you actually click on the wheel, oh no, right, no, you're not going to do it, no. All right, let's get back to our presentation. That was the Revolut Mate demo. Now we'll be going over the slider mate. So the slider mate makes one object slide against another. So one of the most common parts in FTC is a linear slide or any other object for linear movement. This is so that you can reach high on elevators or reach out into different areas to grab things that are far away. So to make linear movement, we're going to be using the slider mate. Now we have our slider mate demo. Now that we're on our Onshape dashboard, we're going to create a new document, and this will be called slider mate demo. I'll call it that. You can call it whatever you want. I'm going to click OK, and we're greeted back with our screen. We're going to go to the assembly portion, and we're going to click insert. Then we're going to go to other documents, my Onshape, and then we're going to scroll down to our Rev extrusion. We're going to click it. Then we're going to click it twice because we want 2 of these for the slider mate. Then we're just going to click the green check mark. Just like we did with the channels, we're going to move one. Let's move it 2 inches away, and that's that. We have our 2 channels. Now we will be doing our slider mate. Right here we have the Fasten Mate, the Revolut Mate, and right next to that is the slider mate. The slider mate once again makes 2 objects slide against each other on a specific axis. So we're going to go to our mate connectors, and we're going to click on 2. Now, there's a really important portion of the slider mate demo, and that's that whatever portion you connect, we're going to be moving along the blue axis, the blue one right there. We have red, green, and blue. So whichever point we choose, we want to make sure that the blue is pointing down. Otherwise, our slide will be going like in a weird, like this way, and the channels actually be going through each other. So we want to make sure we select a point where the blue is pointing downwards. And let's see if we zoom in enough, may be able to find such a point. So this point will work as the blue is pointing upward or downward. It can be either one. So let's select that point right there. Next, we're going to select another point on our other channel. And similar to this one, the blue should be pointing either up or down. So let's select this point right here. Now, if you look closely, linear slides are up and right next to each other. Now, if you see, when we press the play button, one of our extrusions will move up and down. Now, the one thing about linear slides is that they can't go on for an infinite distance and they can't go down for an infinite distance. So we're going to be selecting limits. So our limit, this is the Z minimum. We're just going to keep that as 0 because generally our linear slides, they won't be able to go any more down than they're designed. But our maximum, we have to make sure that the channel can't actually go outside of the channel because that's just not how linear slides work. So we're going to type in 7 for now and see how close to the top that gets us. All right, so it doesn't get us that far. So let's type a bigger number. Let's try 13 inches. I'm going to press play. And great, that's perfect. So generally with linear slides, you're leaving about 2 inches of room at the top, just how they're designed. So if we press play, as you can see, oh, sorry, I clicked the check mark. So yeah, once you're done, you can click the check mark. Then you can also animate this right here, similar to the Revolut Mate. You can click animate, and then the end 0 is the start value, end value is 13, and we'll let it reciprocate, and we can just play. And as you can see, it'll go up and down. If you wanted to make it faster, you can turn the steps to a lower value. I'm gonna try 30. Then if I press play again, it'll go a bit faster. And as you can see, there's space between the top channel and the bottom channel. So it won't go all the way, which is exactly what we want. Now we'll go back to the presentation. The Slider Mate demo is actually our last demo. And thank you so much for listening. Like I said, I'm here on behalf of team 13180 Rover Drive. So if you want to contact us for either the slides, if these are not posted, or if you just want any help with Onshape or actually anything at all, we'll be quite delighted to actually help you out if you have any problems. So for email, our email is ftcroverdrive@gmail.com, all lowercase. Our website is www.roverdrive.net, so you can go ahead and search that up if you want to see what we've done, our accomplishments. And finally, we have our YouTube channel, FTC Team 13180. This actually shows some of our videos, some of our matches. So if you want to see how previous matches worked before the COVID pandemic, you could go and click on that to just check it out. Thank you so much for tuning in and watching this video. Please make sure to, if you want to watch it again, actually, you can always, this will be posted on the YouTube channel, so you can see it there. Thank you so much for watching. And if you have any questions at all, feel free to contact us. Thank you.